This video clip shows various different activities for How Many Ways, which is an excellent way to get children to develop structures for numbers within and up to 10. So we'll start with the beans. These are double-sided, red and white. Nice simple activity because you simply throw the bins in the air and you see where they land. So you can see we have 2 that are red and 4 that are white. So the whole is 6. One part is 4 and one part is 2. And you might just make it look a bit more like the cherry diagram when you record. Throw again. So we're looking at how many ways we might structure 6. And this time we have the whole is 6, one part is 3 and the other part is 3. So that's the beans. Moving on to another context, we've got our cats, 2 cats in a basket, and they love these wool balls, beautiful coloured wool balls. So we've got 4, 5, 6, 7, 8, 9, 10. So we're looking for how many ways we can make structures for 10. Well, we might know our root structure of 5 and 5. So one way is 5 in one basket and 5 in another. One part is 5, the other part is 5, and my whole is 10. So I can record the parts and the wholes on my whiteboard, or I can match them with numerals. Moving these over then, I might take 2 from this basket and put them in this basket. So the whole is 10, one part is 7, and the other part is 3. How many different ways could I arrange these wool balls across the 2 cats' baskets? And how will you know when you have all of the ways? And this is when we begin to be systematic. But we might start by thinking about the fact that I could have 10 here and 0 here, and just moving across one at a time. 9 and 1, 8 and 2, 7 and 3, 6 and 4, 5 and 5, and then we're back to our 4 and 6, 3 and 7, 2 and 8, 1 and 9, 0 and 10. So how many different ways can we see inside 10? And don't forget to record those with our numerals, either by matching with numeral cards or actually drawing the abstract maths. Here we could use our tens frame and these beautiful purple jewels. You can see we have 7. And how can we see our structure for 7? Well, we have 5 and we have 2. So we might record this on our tens frame that our whole is 7. One part is 5 and the other part is 2. We could record that also as a bar model where the whole is 7, one part is 5 and one part is 2. We might look at this another way and see that this is 4 and 3. And again, we might record that on a bar model. We could also take these away and rearrange them. So we might think about these as 6 and 1. One whole is 7, one part is 6, and one part is 1. And so on until we generate all the ways for structures inside 7, and then we might do that with 8, and so on and so forth. Again, always recording with our abstract mathematics. Final example is using Cuisenaire. So we have different rods. 10 of the white make 1 orange. 9 of the white make 1 blue. 8 of the tan, 8 of the white make 1 of the tan. And then 7, 6, 5, 4, 3, 2, and then we have our 1. So we made a staircase, nice staircase with our Cuisenaire. But what if we were to say, how many ways can we make equivalent lengths to orange? So we might start again with our root structure. We know that 5 of the white make 1 of the yellow, and 2 yellows make 1 orange. So this is 5 and 5, and this is our 10. So this is one way of making our orange rod, or one way of making 10 if we view the white as 1. And then if we look at our blue, we can see blue is worth 9 of the white, and 1 more will give us our orange. So these are 2 ways of making our structure for the orange rod. And we go on, tan and red, and our black, and our green, and we've got the yellow and yellow, and so on until we repeat them. So how many ways can we make orange using 2 rods to make equivalent lengths to orange? The Cuisenaires are useful. Initially we work with the colours, and then we begin to think about these colours as numbers. So these are more abstract resource for how many ways.